Okay, guys, so notes for today, that is February 1st, 2021. We were talking about greatest common factor. This is on Go Formative Notes and Examples. So greatest common factor is the largest positive integer that divides evenly into all numbers with zero remainder. So for example, greatest common factor of 6 and 9 is 3, because you can divide 6 by 3 and you can divide 9 by 3, and there's no other factor of 6 and 9 that divides both of them. So this is the greatest one. Okay, for number 2, we have an example of finding greatest common factor when you list the factors. So we had two numbers, 6 and 38. So I took six and list the numbers. So I'm just going in order and divide. I divide by 1, I get 6. I divide it by 2, I get 3. The next number will be 3, but 3 is already here. So they would start repeating. So I know that that's how far I can go. Then 38 divided by 1 is 38. 38 divided by 2 is 19. And we keep going, divided by 3, 4, 5. It wasn't possible. We got to 19. So they start repeating. So the greatest common factor for 38 and 6 is 2, because that's the only one that shows in both of those. So greatest common factor is 2. And then there's another way to do factorization. It's called prime factorization, or the tree factors. So prime numbers are the numbers that divide by 1 or itself. So for example, 2 is a prime number, 3 is a prime number, 5, because 2 I can only divide by 1 and 2, 3 I can only divide by 3 and 1, 5 I can divide by 5 and 1. 1 itself is not considered to be prime. So you make your tree. We had two numbers, 54 and 36. So first prime number, I'm going to try the smallest one, 2. 54 divided by 2 is 27. Then 2 is already prime, so I cannot go lower than that. 27, I cannot divide it by 2, but I can divide it by 3, and that's going to give me 9. And 9 is 3 and 3. Okay, same thing I do with 36. 36 divided by 2, the first prime number, 18. 18 divided by 2 is 9. 9 is 3 and 3. I'm looking for pairs. I have one pair of 3s and one pair of 3s over here. I also have a pair of 2s right here. You're only looking at the end of the tree. Those numbers really don't exist because we already split them. So we're not looking for those. We're looking at the end of the branches. So I'm looking for a pair of numbers, like a pair of 2, pair of 3, and pair of 3. So you're only using the one that repeats in both of them, and that is 2 3s. So 3 times 3 is 9. Your greatest common factor for 54 and 36 is 9. And then we went to factoring monomials. We're going to learn what those are later on. So we got first one was x to the 7 power, y to 9 power, z to 18 power, x to the second power, y to 13 power, z to the 6th power. So you basically take each of those by one. So first I'm only looking at x's. X has 7 power and second power. So basically you're asking yourself, can I put 7 power into second power? No. Can I put second power into 7 power? Yes. How many of those powers are going to fit the most? So what you basically do, you choose the smallest power of each pair, or triples, depending how many set of letters you're going to have. So second power is the one that's going to be my greatest common factor for x. X is the second power. It's the greatest common factor, but we're actually using the smallest power. So then I look at y. Y has power of 9 and 13. So the smallest power that I see is 9. Z has power 18 and 6. The smallest power I have is 6. So your greatest common factor for those two is x squared, y to the 9, and z to the 6. Okay, guys, so we are factoring, for number 5, we're factoring polynomials. Polynomials are connected with plus and minus. We're going to talk about them soon, but for now, let's do the factoring. So you factor the greatest common factor from each number. So I list them 8, 12, and 24. Some of you might know it, that is 4, but some of you might not see it. So I list the factors. It's 1 and 8, 2 and 4 for 8. 12 has 1, 12, 2, 6, 3, 4. And 24 has 1, 24, 2, 12, 3, 8, 4, 6. I'm looking for common number for all of them. If there's more than 2, you're looking for greatest one. But in this case, 4 is the only one that repeats in all of them. So I'm going to write 4. Then I look at x's. Okay, so I got x is 6, x is second, x is third. I list them all. You don't have to list them, but I list them all and I see x squared is the smallest one. So that's the one I can take from all of them. Then I do the same with y. Y to the third power is the smallest one. And then z, there's only one z over here. There's no z here and there's no z here. They don't share the z, so that means we cannot factor this out. So now on the bottom of this, we need to fill out what's going to be left from this after I take all those numbers and variables out. So I wrote my problem from the top over here on the bottom because factoring is opposite of distributing. So basically, I need to find the numbers here to multiply by, so they give me this as an answer. This one is supposed to be my answer. So I need to find what is missing. So distributing means multiplication. So you can do this two ways. 4 times what is 8? Or 8 divided by 4 is what? That is 2, right? Now x to the 6. We took 2 powers of 6. So we have 4 left. Okay, or 2 plus 4 is 6. When you're multiplying powers, variable with powers, you add the powers. Y, we had 3 y's, and we took all 3 y's out. So if you're not missing any, there's going to be no y here. Okay, then I put the minus because that was a minus here, so I keep it. 12 divided by 4 is 3. X to the second power, we took out x to the second power, so there's going to be no x's inside. Y, we took us 3 powers, so I have 6 more. And there was also z that I need to keep. And then 24. 24 divided by 4 is 6. There's a plus. X, we took 2, and so that means we have 1 left. When you put power of 1, we don't really write 1. You can, it's okay, but it's just a waste of time. Everybody knows x means x to the first power. And then we took 3 powers out of 5 powers, so we got 2 powers left. So we just factor this whole polynomial. This is the answer, and that helped me to see that I'm actually doing this right. So tomorrow we're going to practice this. I hope this is going to help.